Hi folks, so we are moving on from where we finished yesterday, where we were looking at that graphing calculator and these questions here. The graphing calculator will be back and we will be practicing lots, so don't worry too much about not feeling 100% comfortable yet. So we're going to start off with relations and functions. Specifically, we're going to be looking only at functions right now. So just in general, a relation is a relationship between a set of ordered pairs, so things like coordinates, and those can be expressed using mapping, like these images here, or graph. Okay, we see them most often in graphical form. And a function is a very specific type of relation that can be defined as one-to-one mapping. So everything from the x or the domain is attached to only one value from the range. So this image is actually incorrect, and you'll see that in your textbook quite a few times. There's some incorrect either images or answers. So each value of the domain can only be associated with one value of the range or many to one. So each value of the domain is attached to 2, but that's okay because 1 is allowed to be attached to 2, 2 is allowed to be attached to 2. We just couldn't attach this value of the domain to another value. So we couldn't have 1 attached to 2 and 1 attached to 3, for example. So that would be something that's considered not a function, but a relation instead. So we're going to go through, can we figure out if something is a function or not? Okay, so in A here, to determine if we're looking at a function, we need to see if the domain is associated with multiple values of the range. So I automatically go and I start looking at my x values or my domain values and seeing if they repeat. Automatically, because we don't see the domain repeat, we can say yes, that is a function. Whereas in the second one, when I go through these coordinates, I see that 5 is associated with 20 and with 25. Okay, that does not fit the one-to-one mapping or the many-to-one mapping. Okay, so this is not a function. Well, this is the perfect definition of one-to-one. Each value of the domain is only attached to one value of the range, so yes. Whereas here, the x value of the domain is attached to 2 values of the range, so that would be a no. Okay, and then in these ones, you're welcome to either draw a little diagram for yourself, or you can plug in x and y values kind of and create your own table of values or your own coordinates and see if it's going to generate something that is considered a function or not. Something that's linear like this is always a function. If I were to draw this, it would cross at +7 and have a slope of -3/1. Oops, sorry there. Okay. So it would automatically pass the vertical line test, which is a way of determining if something is a function or not. So if your vertical line passes through your function, or sorry, through your graph more than once, it means that the x value is attached to multiple values of the range. Okay, so in this case, my vertical line test only crosses once, so a function. For this one, we can try to do the same thing. You could absolutely generate a graph for yourself if you want, or you could create a table of values or coordinates and analyze to see if it fits the requirements for being a function. So let's plug in a couple points here and see what happens. So when I plug in 1, I get square root of 1. When I plug in 2, I get square root of 2. Plug in 3, square root 3. Plug in 4, get square root 4. So every time I have an input or a value in the domain, I have a unique value in the range, which is a one-to-one mapping. So yes, it is a function. Okay, we got some graphs here. Again, remember if you have a continuous graph, so lines that create a graph, you are allowed to use the vertical line test to deem if it is a function or not. So take it, draw a line, draw vertical lines. Mine are a little skewed there because I'm drawing them by hand, and they should only cross the graph once if it's a function. So that's good. Well, each time I draw a vertical line here, I only cross once, so also good. But when I draw a line here, it crosses twice, which basically means that if I were to create a table of values for this, 1 the value x1 would touch both 2 and it would touch 8, for example. So the domain repeats itself. Okay, let's keep going with functions. So now we're going into function notation. Okay, so it often looks like f with an x in brackets or g with an x in brackets, but it can absolutely be different letters than an f and an x or g and an x. Those are just the most common. We typically say this as f of x or g of x. Okay, and we're going to do some calculations using function notation, but remember, function notation just helps us express that we're trying to do a substitution. So it's an abbreviated way of stating a substitution instead of writing out x and y. Okay, so let's calculate the substitutions or what we need to find here. So g of x is going to be a set of coordinates here. Okay, and we're looking for g of 8. Okay, so inside the bracket here is an x value. So we're looking what happens when x is 8. So I can go down this list and find when x is 8. And we're going to get, oh, sorry, that should be an 8 there. And we're going to get 9 as a solution. Okay, so the output is really kind of like your y value or your range value. For here, f of x, negative 2x minus 1, f of negative 3. So again, x values replaced, so we're going to replace x here with negative 3. Okay, and I'm going to also replace over here with negative 3. And a quick reminder, this does not represent a multiplication. This is notation, just saying f of negative 3, f when the function when I place negative 3 within it. So we have positive 6 minus 1 or 5. Okay. For this one, you can also represent function notation with this. So f dot dot x. It's exactly the same thing as writing this one here, f of x. This is f of x as well. So you can write it like this and replace x with 1. So I'm going to right here replace x with 1. 3 times 1 plus 7. So I get 3 plus 7 is 10. Okay. For D, when I'm looking for h of negative 1, well, I can substitute h of negative 1 in. And there's 3 on the other side, so there's nowhere I can place negative 1 in. So this just means that the output is 3 every time. No matter what value of the domain I place in, I'm going to get 3 as my solution. And then the last step is f of 4 for this graph. So again, the x value is 4, just here. So I'm going to travel up and find the y value there. So f of 4 is going to generate the value y, the value 5, sorry. So again, some calculations. We'll just do one of these and then we'll flip over to these two. So let's say I wanted to find f of 100, for example. Oh, actually, let's go with f of 0. So f of 0 is equal to negative 3, 0 squared minus 1. So again, replace your x values with 1. F of 0 is equal to negative 3, and 0 times 0 is just 0. So this is really just negative 3 times 0, which is going to give me 0. Okay? And then that leaves us with just the negative 1. This would be an unnecessary, you wouldn't need to write this step. I'm just writing it to make sure I'm being clear. You could absolutely go from there to there. Okay, for D, let's try it with A. So f of A is equal to negative 3a squared minus 1. At this point, I cannot solve because I have a variable. I cannot isolate or simplify any further. So I stop there. This is my final answer. And for this one, we're going to have f of x plus 1 is equal to negative 3x plus 1 squared. So I'm going to simplify on the right-hand side. So I start off with that x plus 1 squared. So that's going to give me x squared. And remember, this is just the calculation that I'm doing. So I'm going to get x squared. I'll have 1x, another x, so I'll have 2 x's, and I'll have plus 2. Okay. Then I'm going to expand in this negative 3. And then combine like terms. Oh, that should be a minus. And there we go. We are as simplified as possible. Okay, we have a problem here. So we're given a situation. This is an example of function notation when it's not written as f of x or as g of x, where it's using letters like v and d that represent units in the problem. So this says the formula to calculate the volume of gas in a car tank in liters after traveling d kilometers is v of d is equal to negative 0.115 d plus 60. So explain what V of 250 means in the context of the question and calculate its value. So I'm going to start by calculating and then we're going to talk about what it means. So V of 250 is equal to negative 0.115 times 250 plus 60. Ooh, unnecessary bracket there. If I were you, I would just simply plug this into the calculator to find the final answer. So it's, if you do this full calculation, you get 31.25. Okay, so this represents, the D is the distance. So this person has traveled 250 kilometers. Okay, and has used 31.25 liters of gas. Oh, actually, sorry, this not used. This is what's left. Okay. We can do something very similar with B, but this time it says V of D is 10. So instead of replacing D with 10 this time, I'm going to replace V of D completely with 10. And the goal is to solve for D, so I would start by subtracting 60. So now we have negative 50. And then divide both sides by this decimal. When you do so, you're going to end up with about 434.78. But you can absolutely round it in this case. So I'm going to write 435 is the distance. So in this case, after 435 kilometers, there is 10 liters of gas left. Okay, and then last up, this is a contextual, well, do you understand what's happening? What values of D don't make sense in this scenario? D represents distance. So absolutely no negative numbers. Okay, it doesn't make sense to be having a negative distance. Okay, there's also going to be a maximum distance that the vehicle is able to travel on a tank of gas. So we could say that it's going to be a restricted to a maximum distance, which we can call whatever we want. You could call it N, you could call it P. Okay, so this will be the maximum distance. Okay, there's going to be one quick little follow-up question here. So the last one is Nikita's planning a sports banquet. He must pay $320 to rent the room and $20 per person for the diner. Express the total cost C as a function of the number of people who attend the banquet. Okay, so we're looking at a kind of linear function here. So it's $20 per person, which is N. So 20 times N plus the rental fee plus 320. Okay, so this is the general part. Now we need to make it into a function. So we would note that as C of N is equal to 20N plus 320. Remember, The C really represents kind of like the Y value here. The N is what was representing our X or our domain value. I'll finish this up on a quick video, so check that.